I just saw Metashape Professional and the RTX Pro 6000. They go together like peas and carrots, definitely not like nuts and gum. This is a dual RTX Pro 6000 system because I wanted to test both GPUs, like two GPUs in this, but this is also a system that is 5 times faster than a 5090. Is that because of the EPYC 9575F? No, 9950X versus 9575F, we're also going to take a look at that. But photogrammetry is another thing that benefits from having a tremendous amount of VRAM and ridiculously powerful GPUs like the Blackwell RTX Pro 6000. Let's take a look, let's discuss. This system behind me is equipped with two RTX Pro 6000 Blackwell generation GPUs from NVIDIA. They're less expensive than Hopper, the H100s. They're a little bit more expensive, about the same price. Initially, supply chain has been weird of the RTX 6000 that came before them, the Ada generation. So these are the successors to that. And these look kind of like gaming GPUs. These are the 600 watt versions of these cards. This is also not an optimal layout, having the two GPUs on top of each other. This is just for testing. I have a big fan pointed at this, which is part of the noise problem in this room. This is running on a Supermicro H13 motherboard with an AMD EPYC CPU. That's 12 memory channels. This platform does not want for memory bandwidth. This is also the EPYC 9575F. Now, if you followed my other videos when we're doing AI experiments or loading things from ridiculously fast storage, memory bandwidth and this platform does make a big difference. So the 9575F is a dual GMI link. This is the fastest platform for feeding PCI Express 5 peripherals in general, and in particular, the fastest platform that I have for testing the RTX Pro 6000s. The rest of our system is a Silverstone special, basically. It's the Silverstone CETA case that I reviewed separately. The power supply, 1600 watts. That's how we have our dual GPU power, 600 watts, remember, plus our 500 watt CPU, and we're not tripping the breaker. This is one of the few power supplies that can actually do this. And our cooler, it's a Silverstone AIO, an all-in-one cooler for EPYC. Yeah, it's a little challenging to cool a 500 watt CPU with a tower cooler. So this is the setup that we have in our workstation. It makes a pretty fine EPYC workstation. But in this video, all we're really looking at is the Metashape Professional software and a relatively large photogrammetry data set and how that scales from a 9950X with a 5090, which is about $10,000 less expensive than an entry-level system that has just one of these RTX Pro GPUs. When you order one of these $10,000 GPUs, it's a lot like getting a 5090, right? I mean, you order a 5090, it comes in a box like this, it's fancy. You can, you open it and yeah, there's nothing in here. But NVIDIA is all about the unboxing experience with the 5090 or the 5080 or even the 5060, I think comes like that. No, these come in a box like this. There's some padding and it's a simple cardboard box. This is, $8,400 to $10,000. MSRP is $8,500, give or take. So it's a little over the top, a little ridiculous. But hey, I'll take it, it's totally fine. It does game, you can game on this. It's actually faster than a 5090 for gaming, but really, let's talk about the data set. How big is the data set? It's 1,000 images and it has 2 million points. Basically, the way that photogrammetry works is you have a drone or some other image source, satellite sometimes. Satellite will take a bunch of pictures. Sometimes the satellites can actually do laser range finding fairly accurately. Sometimes you see videos, looks like some sort of alien happening, like out in Hawaii. It's like there's green dots and there's crazy stuff happening. That's just a satellite doing geo-survey type stuff with a low power laser that you normally can't see due to light pollution. That's not what this is. This is drone photography, but this is a very large data set that a member of our forum supplied so that I could run tests. And in running the tests, we wanted to see how it would perform with a single 9950X and a 5090, and sort of using that as our baseline. Actually, we used a 4090 as our baseline. From the speed up from the 4090 to the 5090 was like 122%. So that's a pretty significant improvement gen on gen. But the 5090 only has 32 gigs of VRAM. The Blackwell Pro RTX 6000 has 96 gigabytes of VRAM. That is the biggest difference between these cards. These cards are 600 watts, a 5090 600 watts. They have roughly the same computational capabilities. Technically, the RTX Pro 6000, more of the power budget goes to the memory than the cores, so the cores are actually a little bit slower, but there's more ROPS and there's more raw processing capability, for an inexact way to describe it, on the RTX Pro 6000 versus the 5090, but mostly raw computation, the 5090 and the RTX Pro 6000 are pretty evenly matched. The edge cases that I just mentioned notwithstanding. Nevertheless, for this job, a single RTX Pro 6000 is 5 times faster for the step that involves loading textures into GPU memory and processing them. When the 32 gig 5090 runs out of memory, it can still load the textures, it can still do the processing, but it's using the PCIe bus and system memory to juggle all of the data points, and there's really not enough VRAM to deal with that volume of data. In this case, we can look in the logs and we can see that we have regular excursions to 48, 50, 54, 60 gigabytes of VRAM. It doesn't seem like it's using the full 96 gigabytes of VRAM, but it does help tremendously. It's a 5x speed up. The next thing I was curious about was how much does adding a second 5090 improve the situation, and how much does adding, going from 16 cores to 64 cores on the 9575F. The 9575F is a very special processor, you have to understand. This processor from AMD, it's 64 cores, and yeah, AMD has 96, 128, 192 core CPUs, but this 64 core CPU has twice the bandwidth from each core complex to the memory subsystem. So this thing is built to saturate Infinity Fabric, and it's built to saturate Infinity Fabric without requiring the use of 96 or 128 cores in order to do it. These 64 cores can use every bit of the Infinity Fabric bandwidth, a PCIe bandwidth in the entire system. That shows for network I/O, that shows for GPU I/O, that shows for machine learning tasks, and I was not super surprised that for photogrammetry, it also helps tremendously there in terms of loading data. But this particular piece of software is not super multi-core threaded, it turns out. There really isn't a huge performance difference between 16 cores and 64 cores. And keep in mind, the 64 cores here, they're running at 5 gigahertz. They're no slouch. This is a ridiculously fast platform. I mean, our CPU can use 500 watts versus 120 watts for a 9950X, give or take. So for CPU scaling, for everything else, this CPU scales great. For this piece of software, it doesn't scale great, not on the CPU side of things. The GPU side of things, it scales better, but it's still not perfect. So our benchmark results get a little interesting when we add 2 GPUs to the mix. The 9950X seems like it's having a little trouble feeding both GPUs, where it has no trouble feeding a single GPU. 2 monstrous GPUs, maybe it's on the struggle bus a little bit. We're in a situation where, okay, would it make more sense to have 2 9950X workstations, each with its own GPU, or does it make more sense to spend the extra money and build a server platform like this for that? I have a feeling that it's going to depend on the data set. Our data set here is large, but it really isn't absurdly large. And I think that makes a difference, and that should be something we test additionally, I think, because this system is sized for a very, very large data set. At the same time, I wanted to run NVTop, which is a utility for monitoring how busy the GPU is. And I was surprised because most of the processes, see, as the software runs, you can see there's individual results here in the output. Some things take 5 minutes, some things take an hour, some things take 8 hours. It just depends on what you're doing. And as it goes through each section, some things are CPU bound, some things are GPU bound. But even in the GPU bound sections, looking at the graph output from NVTop, it's really not effectively utilizing both GPUs. Both of these GPUs can draw 600 watts and will consume 600 watts when they are 100% loaded. We see that with AI workloads, we see that with other types of workloads. But for this workload, the amount of VRAM that is being used and how utilized the GPU is varies from 1 second to the next. And it does have a benefit from keeping both GPUs busy, but both GPUs are not fully 100% busy. I have a feeling that this generation of hardware means that this software company is going to need to do some further optimizations to their software in order to better feed both GPUs. Now for these results, I'm sort of two minds of this. You know, it might make more sense to go the multiple 5090 route with 9950X because Metashape does support network rendering and that will split up the job. If you're doing texture a lot, I could see that the 6000 being, you know, about 5 times faster, give or take, would make a lot of sense. But there's a lot of steps involved here, and if you look at the total amount of time spent on each benchmark, maybe it would make more sense to just have multiple 9950X machines with multiple 5090s. It really depends on what you're doing with Metashape. Not everything is going to benefit from the RTX Pro 6000. That said, if you're doing texturing, there is no substitute for the 96 gigs of VRAM on the Blackwell Pro 6000. Linux as a platform is definitely my recommendation for this piece of software based on the evaluations that I've done so far in this particular data set. I'm using the long-term version of Ubuntu, just FYI if that helps you. But it was pretty easy to set up. I didn't have to jump through any hoops. You can install Ubuntu, set it up, load the software. You gotta get the NVIDIA drivers, NVIDIA Blackwell drivers. I wrote a how-to for that on the Level 1 forums, but that's pretty much the long and short of it. There's the benchmarks, there's the numbers, there's how it performs. There's definitely room for optimization, and there's definitely room to revisit this in the future. So if you're interested in this project or this data or this kind of benchmarking, definitely engage on the Level 1 forums because that's how I did this in the first place. So huge thank you to our forum members for participating in this and providing some data. And there's some awesome photogrammetry on the web that you can check out that's, you know, from the same people. So it's very awesome. Thank you. And that's pretty much it for this one. This is Level 1. If you have any questions or I missed anything, hit me up in the forums. I'm signing out and I'll see you there.